Good morning to the viewers. Last lecture we have been listening the basic radiation physics that discussed about the various radiations and its properties. Today we are going to talk about sources of radiation. What is the relevance of this lecture? Many people believe that radiation comes only from hospitals during X-ray, during tendal radiography and during CT scan. It is not so. Radiation is present everywhere. Every part of the globe there is radiations are available and we have been exposed to radiation. So this lecture try to bring out what are the various sources of radiation in the universe and how every human being is exposed to it. Let us go to the first slide. Every day we are exposed to radiation from various sources. These radiations arises from natural radiation sources, artificial radiation sources, or it is also called man-made radiation sources. Sometimes we get employed in a radiation facility that people get occupational exposures radiation, or somebody can work in mines, uranium mines, they will get occupational radiation exposure. In general, background radiation consists both natural and artificial radiations. The background radiation varies from place to place and country to country. For example, if you take in India, Kerala has highest level of background radiation of 12.5 millisievert. If you take Brazil, it gives around 260 millisievert per year. Likely, the background radiation also varies from city to city. The annual effective dose everybody receives is around 3 millisieverts, which will slightly vary from place to place. This figure tells you exactly how much the proportion of radiation we are receiving. For example, natural background radiation consists of 82%, whereas man-made radiation consists of 18%. The man-made radiation arises from these components. That means the majority of the man-made radiation from medical X-ray around 58%. Next is nuclear medicine procedures 21%. Next is consumer products 16%. Next is occupational 2%. Nuclear fallout 2%. Nuclear fuel cycle 1%. Let us discuss about the natural radiation. The natural radiation consists of 80% of the exposure. It comes from radon, cosmic rays, terrestrial and internal radioisotope. Radon constitute around 55%, cosmic rays constitute around 8%, terrestrial radiation constitute about 8%, internal radioisotope constitute about 11%. This table tells you how much radiation we are receiving in terms of millisievert from each sources. For example, you can see there cosmic rays gives around 0.4 millisievert per year. Terrestrial radiation gives around 0.5 millisievert per year. Of course, this is a range of values are given in the bracket. Radon inhalation gives around 1.2 millisievert per year. Ingestion, the food we are taking, that gives around 0.3 millisievert per year. Medical exposure gives 0.4 millisievert per year. Nuclear testing leads to 0.15 millisievert per year. Nuclear power production gives you very less value, so that the total amount of radiation everybody receives is around 2.95 millisievert or simply 3 millisievert per year. If you see in the table, you can see that radon inhalation is the most contributor and gives around 1.2 millisievert per year to the every individuals. Next, coming to the cosmic rays, where from the cosmic rays comes? The cosmic rays come from the outer world. It reaches the earth and exposes to everybody around 0.4 millisievert per year. The cosmic ray consists of mainly protons and alpha particles. The cosmic rays can be classified as primary cosmic rays and secondary cosmic rays. Primary cosmic ray consists of 80% protons. These protons interact with the atmosphere and produces secondary particles which involves electron, muons and electromagnetic radiation. Cosmic ray exposure increases with altitude and doubles in every 1500 meters. So higher the altitude we travel, higher the cosmic ray exposure. Cosmic ray exposure also greater in poles than equator. Any person going to the pole may get a higher percentage of cosmic rays. An air traveler exposed to increased level of cosmic rays because they are at a higher height, altitude. It is estimated that air travel in a transcontinental flight may receive 5 millisievert per year at the rate of 10 millisievert per hour. Structures may offer protection against cosmic rays, hence indoor effective dose is always 20% lesser. Hence, people living inside a shelter get lesser cosmic ray exposure. Next, terrestrial radiation. The terrestrial radiation exists since from the formation of the earth. It is due to the materials and minerals in the earth. It arises from external exposure, inhalation and ingestion. External exposure is source is outside the body. Inhalation is the air we breathe. Ingestion is the food and water we drink. External exposure is caused by potassium 40, uranium 238, thorium 232. The biggest contributor is radon 222, which offer around 2 millisievert per year. The radon arises from uranium 238 from soil. It is a basically alpha emitter with a half-life of 4 days. The inhalation mainly from radon 222 and its decay product. Radon daughters attach to aerosols and may deposits in lung. It contributes bronchial mucosa, may induce bronchogenic carcinoma. So basement, low-rise buildings, non-ventilation rooms may have more radon concentration. The granite we use in the construction material may offer more radon concentration. Internal exposure is due to radioisotopes present in our human body. What are the radioisotopes we have in our body? Potassium 40, carbon 14 are the main radioisotopes we have in our body. Among the two, the main contributor is potassium 40. It emits beta and gamma rays, but the level of radiation is very insignificant compared to the other radiation values. This slide shows the background radiation and individual dosimetry in coastal area of Tamil Nadu, India. University of Nagasaki recently undertook some radiation measurements at the coastal area of Nagarkoil area and come out with a publication which is telling that the minimum radiation is 2.79 millisievert, the maximum radiation is 14.17 millisievert. If you take the mean value, around 7.17 millisievert. That means the people living in the coastal area of Nagarkoil receives around 7 millisievert radiation, which is almost equivalent to taking one CT scan, thoracic CT scan of the patient. That means these people are not having any undue effect in the body. That tells that radiation doing hormesis effect. Let us discuss about artificial radiation or man-made radiation. Artificial radiation consists of medical exposure we undergo, that means diagnostic X-ray, tendal X-ray and then bone densitometer and radiation treatment for cancer. Then consumer product also contribute to artificial radiation, and then occupational exposure, that is if you are an employee in a radiation facility, that may leads to occupational exposure. The man-made radiation is around 18%, we have seen in the first slide. This consists of medical X-rays, nuclear medicine, consumer product, occupational, nuclear fallout and nuclear fuel cycle, etc. Let us discuss about medical exposure. Medical X-rays and nuclear medicine are the major contributors. So, medical X-rays consist of diagnostic X-ray, general X-ray, radiography, fluoroscopy, CT scan and Tyndall X-ray, etc. Nuclear medicine procedure is involving radioisotope, open radioisotopes using gamma camera, PET CT, etc. Both gives an effective dose of about 0.4 millisievert per year. It consists of around 79% of the artificial radiation. So, medical X-rays mainly arises from fluoroscopy and CT scan. Fluoroscopy include interventional radiology and interventional cardiology. If you see per procedure how much radiation we are exposed. For example, if you take one CT, the amount of radiation is 6.6 millisievert. If you do one interventional procedure, radiology procedure, it gives around 8.6 millisievert. In nuclear medicine, it is 11.6 millisievert per procedure. Of course, the mammography and Tyndall radiography giving the radiation levels but which are insignificant compared to the above levels. Just a comparison, what is the percentage of use of each medical procedures and how much contribution of dose it is giving. For example, you can see that radiography use is around 70%. The amount of radiation dose contribution is only 20%. Though it is very higher in use, but the radiation levels are very less. You see the CT scan, the percentage of use only 8%, but the radiation dose level is 48%. It's very high. Similarly, fluoroscopy, the use is only 3% or interventional radiology, but the contribution of radiation dose is 30%. So, if we combine the use of CT scan fluoroscopy, 8 plus 3, 11% only we are using, but the radiation we are getting is 30 plus 48, 78% dose it is contribution. That tells you that anything you want to reduce the radiation effect in medicine, it is only the interventional radiology or fluoroscopy or CT scan. We have to do some safety measures to reduce the radiation to both employees as well as the patient. Let us discuss about the consumer product which contribute to artificial radiation. The tobacco is the main source of radiation from the consumer product. Then radon gas dissolved in domestic water supply, that is in drinking water, is also the next contributor of radiation in artificial. Building material, construction material like brick, granite, concrete, these are all used for construction which may give to radiations to the public. It is basically consist of this material uranium, thorium, potassium are present in construction material. Fertilizers using in agricultures consist of uranium, thorium, decay product of K40. This also contribute to artificial radiation doses. Not but least is the combustible fuel involving coal and natural gas. To summarize, radon is the most contributor in artificial radiation. It gives around 160 becquerels per meter cubed. Becquerel is the unit of radioactivity named after the scientist Henry Becquerel, and the SI unit of radioactivity. The special unit is Curie. In addition, consumer product involves smoke alarms, gas lantern mantles, Tyndall processes, certain ceramics, optical lenses, television and computer screens. Smoke alarms involve americium-241, gas lantern mantles involve thorium, optical lenses may involve uranium. Consumer product in totally accounts 0.1 millisievert per year and it is 16% of the artificial radiation. So this slide tells you What are the radiation dose to the occupational workers? What are the various occupation we come across with radiation? For example, uranium miners, nuclear power operators, medical diagnosis and therapy workers, aviation research areas, non-uranium mining, phosphate fertilizer industry. These are the various occupations people are working. And let us see from the table who is getting the highest radiation level per year and who is getting the least. For example, uranium miners are getting around 12 millisieverts annual dose. Nuclear power operator comes next, 6 millisievert per annum. Airline crews 1.7 millisievert per annum. X-ray and nuclear medicine technologists getting 1 millisievert per annum. Radiologists are getting 0.7 millisievert per annum. This table clearly shows the highest radiation dose comes from the uranium miners occupation. Similarly, the lowest radiation dose comes from the medical industry, that too radiologists and the X-ray and nuclear medicine technologists. Occupational exposure also comes from atmospheric testing. It emits carbon 14, hydrogen 3, manganese 54, cesium 136 and 137, barium 140, cerium 144. Plutonium, trans-plutonium elements. Nuclear fuel cycle contribute around less than 1 millisievert per year. Radioactive fallout contribute around less than 1 millisievert per year. In artificial radiation, most contributor is carbon 14. Is there any place without radiation? You can see the picture and you can tell what are the various sources of radiation we are exposed in our daily life. Start from solar radiation. Solar radiation we are exposed from the sun, and then consumer product also we are getting radiation. Then radioactive waste, both in medical waste and industrial waste we are exposed to radiation, and terrestrial radiation coming from construction of the building and the materials we are using in the building material, we are exposed to radiation. The food and drinks we make also gives actually the radiation. Suppose there is a hypothesis, if you take 4 bananas per day, it is equivalent to the radiation of bone mineral densitometer used for calcium analysis. Similarly, nuclear power reactor also contribute radiation. Even humans, within the humans, we have internal radioisotope. These radioisotope give exposure to individuals as well as the person sitting around. And radon is another major contributor of radiation. Of course, cosmic rays we have discussed. This also gives a lot of radiations to the public. And the medical X-rays we are taking for general radiology and CT scan, etc. And the nuclear medicine procedures using open isotopes in gamma camera, PET CT scan, this also gives. See, overall this tells you that we are all exposed to radiation from various sources, whatever the place we live, whatever the nation we live. So there is no place in the earth without radiation. So in summary, we can say that radiation arises from natural sources, artificial sources or man-made sources, and due to occupational work. Radon inhalation is the major source of radiation exposure. In medical, CT scan, interventional radiology are the major sources in artificial radiation. Uranium miners and air crews exposure is higher than the medical workers. There is no place in the world without radiation. One has to learn to live with radiation. I hope everybody has enjoyed the lecture. Kindly subscribe to enrich your knowledge. Let us meet in the next lecture. Thanking you.